As we are going to be looking at integration by parts. Now we have what we call the ILATE rule. What is the use of this ILATE rule? At times you can be given an integral like this. For example, let me take an example down here. Now you can be given an equation like this. Integrate. You have maybe 2x cos x with respect to dx. Now for you to integrate this, many students usually get confused to know which one they will let as u, and you have another one like this again. So we are going to be solving that problem in this video so that you should never get confused to know which one to take as u, because if you are taking the wrong one as u, you will end up having the wrong answer. Now with respect to dx also, so we also have e to the x sine inverse of x dx. So these are some few examples, there are many more. So now I want us to define the ILATE rule. The ILATE rule helps us to choose the correct u substitution. That's it. Now I stand for what? We have the first one here, which is I. This I stand for inverse trigonometric. Yes, like in this case, the inverse trigonometric here is sine inverse of x. So we're going to be taking let u equals to sine inverse of x in that case. Now another one is, the next one we are having here is L. Now what does L stand for? L stand for logarithmic. Yes, logarithmic. For example, let me give an example in this case. So for logarithmic, if you have integral of, if you have e to the x log x, or let me say ln of x, now with respect to the x, of course. Now in this case, following the ILATE rule, you are going to look at which one comes first before letting as u, of course. So in this case, we have e to the x, we have ln of x, so I'll say let u equals to ln of x. That's it. Now A stand for algebraic, T stand for trigonometric, and E stand for exponential. Exponential in this case is this one. Yes, for trigonometric is this one. Don't get confused between inverse trigonometric and trigonometric. Inverse trigonometry was in the case whereby we have e to the x, you can have maybe integral of e to the x, sine inverse of x, cos inverse of x, tan inverse of x, and so on. Those are some few examples. Now, so we also have the last one, of which we are having here. We have exponential, which is this. So exponential should always be the last. Yes, it should always be the last. So that's the order. The order is ILATE. Let me repeat again. I standing for inverse trigonometric, R standing for logarithmic, A standing for algebraic, T standing for trigonometric, and E standing for exponential. So that's it. Now we can take our very first example, and we solve it using the ILATE. So now you can ask us to evaluate this. You can have integral of, let's say number 1, integral of, we have x tan inverse of x with respect to dx. Now that's a nice question. They want us to integrate this. Now to integrate this is what I'm going to do. Sorry, let me erase this. So to integrate this, we are going to choose the correct substitution. So say let u equals to, when we are following the ILATE, you see that inverse trigonometric stand comes first, which is why here we have tan inverse of x. So that's it. So from there now we can have du, differentiating that, we have 1 on 1 plus x squared with respect to dx. Next, we are going to also look at the next one, which is we also have dv. So also have dv will be equals to x. Now, when we are looking at this, to integrate this, we are going to integrate both sides. Looking at this, we are going to integrate both sides. Integrating both sides, we have this implies, we have this implies, when you integrate v, we have v. When you integrate x, sorry, that was with respect to the x. When you integrate x with respect to the x, we are going to have x squared on 2 plus a constant c, because limits were not given. But let me just put just that for the meantime. Now, when we look at this, the next step is that we are going to substitute right in that formula. We had integral of u dv equals to uv minus integral of v du. So we are going to be obtaining, so let's substitute that u. What is our u there? Our u, we obtain u as tan inverse of x. So we're going to be putting that tan inverse of x times v. What's our v? Times x squared on 2, that's it, minus, that is uv. What is our u? Our u is minus the integral of uv. Our u is still x squared on 2 times. Now, what are we having here? So we also have, look at the formula. The formula is u du, then the formula is v du minus integral of v du, uv minus integral of v du. So we have substituted already uv minus integral of v. What is v? This is v here. Now, where is du? We also have du as 1 on 1 plus x, all that squared dx. So that's what we are having for that. So I also go and substitute that. Let's substitute that. So we have times, we have 1 divided by 1 plus x squared, all that with respect to the x. So that's it, guys. That's it. So now let's integrate this. So let's continue integrating until reach our final answer. So from here we're going to have, this is equals to, so we have x squared, so we have x squared on 2 tan inverse of x minus, I can factor out this half. If you factor out this half, you'll be left with 1 on 2 integral of x squared times 1 on 1 plus x squared dx. So the next step is that we are going to simplify. So we have x squared, that's x squared divided by 2 tan inverse of x minus a half into, now if you are integrating, we can do this. You can multiply this, so we have x squared on 1 plus x squared with respect to dx. So from here, now all this, right, all this, so we are having x squared on 1 plus x squared is identical to 1 minus, this one can be written as 1 minus 1 on 1 plus x squared. Yes, all this is identical to that. It's true, we can add to confirm that we have 1 plus x squared, 1 plus x squared minus, now this divided by this, that's 1. So we end up having something like this. One can cancel out 1. We end up having x squared divided by 1 plus x squared, which is the same. Are you seeing that? They're all the same when you look at that. So in other words, why am I doing this? To make it easier for me to do the substitution. So instead of integrating it directly, that's what I'm going to do. So I have this is equals to I have x squared on 2 tan inverse of x minus half integral of 1 minus 1 on 1 plus x squared, all that with respect to what, dx. So after doing that, the next step is that now looking at this, we have x squared on 2 tan inverse of x minus, now I will integrate this separately, right? Integrate this separately. So you have half of 1 dx plus, let me do this separately. So half, that is still negative half. So I can keep out the negative half to make it easier. Let me keep out this negative a half into what? Integrating everything in brackets. So we have integral of 1 on, now but what is the integral of all of this? What is the integral of all of this? So we have the integral of 1 divided by 1 plus x squared with respect to dx. Let me close the bracket. So we'll continue integrating. So we'll have x squared on 2 tan inverse of x. Now if you integrate, so we have negative a half into, if you integrate 1 dx, you are going to end up having x, now plus, if you integrate 1 on 1 plus x squared, you are going to have tan inverse of x. That's it. So the rest of the step here, it was just simplification. So now, in other words, we can factor out the half throughout, or we stop here, because if you open the bracket, you are still going to maybe factorize half at the end out, so no need again. So that was our final answer. Please subscribe to this channel. If you have any question, do that in the comment section. You can write that question in the comment section. I'll get back to you and solve that question step by step while explaining. Now we can move ahead. Let me not call this the answer. So let's move to number 2. Now number 2 will be an easy question. We have integral of x cos x dx. Now let's integrate this. Now following the ILATE, which one comes first? Following the ILATE, we have ILATE. Always write this down. Remember, I stand for inverse trig. We don't have inverse trig there. We have L stand for logarithmic. We don't have algebra, which is x here. So we are going to be letting x first. T stand for trigonometric. So we say let x equals to u. So we say let u equals to x. So we have du is equals to, differentiate this, we have 1 dx. Also move to dv. So also have dv is equals to cos x. Now we can now integrate this with respect to what? With respect to x. So v will be equal to, integrate this with respect to dx. What are we going to have? We are going to, remember, when you differentiate cos x, you have negative sine x. Remember, negative sine x. But when you integrate cos, you instead have a positive, so it's the reverse. You have sine x, which is positive. So we can now start substituting. Remember, our u is x. Our u is x. So we have integral of u v. So we have u v, which x sine x, minus integral of u. Where's our u again? Our u is x. Integral of x So now looking at this, right, we're going to be taking, you have uv, we have already done that, minus v, integral of v, should be v here, and that v here is sine x. So we have sine x du. What is our du? Let me look at our du. Do we have du here? Du here is 1 times sine x remain unchanged, so no need to put in 1 there. So that's it. So rest now just simplification. So copy it back, sine x minus, now when you integrate sine x with respect to dx, remember when you differentiate sine x you have cos x, so when you integrate now, rather you have negative cos x plus c. Remember, this last one that the first one that we solve, you must put plus c or k because limits were not given. So do same here. So our final answer will be, after opening the bracket, we have x sine x plus cos x plus c, which is our final answer for that question. Now let's move ahead again. We also have another one here. This number 3, we have integral of x e to the what x dx. Looking at this, looking at ILATE, exponential is the last here, is the last, so we start with x. So say let u equals to x, du is equals to 1 dx. So also have dv will be equals to e to the x, and v, integrating that, you are going to have v as e to the x again. When you integrate e to the x, you have e to the x. When you differentiate e to the x, you will also still have e to the x. Now you can just start substituting. So we have uv, our u here is, our u there is x, our v is e to the x. So do that substitution. So we have, you are doing that, you have x e to the x minus the integral of e to the x times, that's v, times du. What is our du? Our du there is 1 dx, so times 1 dx, so we end up having x e to the x minus, when we integrate e to the x, we are going to have e to the x plus c. Yes, you can even go further by factoring out e to the x into what? X minus 1 plus c. So that was the final answer for that question. Please, if you have any question, you can do that. You can comment in the comment section and I'll get back to you and I will answer your question. Please make sure you also share this video. Sharing this video will encourage me to upload more contents like this. Please share this video much as possible. Now let's move ahead. Let's move in the case whereby we have, that's number 4. Number 4, we have integral of x ln 2x. What are you going to have at the end with respect to dx? So we're going to have, now looking at this, looking at ILATE, right? ILATE will tell us that link come before algebra, so take that link to be u first. What are we going to be doing here? So we say let u equals to link 2x. So let u equals to link of 2x. Now we have du will be equals to, we are differentiating that, so we are differentiating that. We have, now when you are differentiating this, you differentiate 2x, you have 2 divided by all what you had, which is what again? 2x. Just like you have link x, when you differentiate x, you have 1, all that divided by x itself with respect to the x. So at the end of the day, you still have respect to the x, so that the 2 can cancel out, the 2 still have 1 on x. So let's move ahead. So we also have what again? We also have dv will be equals to x. So v, integrating both sides, you have v as x squared on 2. Let's move ahead. So now looking at that, you have uv. What is our u? You have uv. Our u there was, looking at that, let's go back and check what you have there. Looking at that, we have our u as link 2x, u as link 2x times, so we have 2x times x squared on 2 minus integral of, we have integral of v. What is our v? V du. So what's our v? We have our v as x squared on 2 times du. Our du is what? 1 on x. 1 on x. So we have integral of x squared on 2 times 1 on x with respect to dx. So again, let's proceed. So we're going to simplify this much as possible. So we have these 2 can start taking care of these 2. So we have x times x squared, that's x cubed, minus, also this one of these x can take care of this one of these x, so we're left with x on 2, the integral of x on 2. I can factor out this half, then I integrate x with respect to the x. So looking at that, we will move ahead. So we'll have this is equals to x cubed minus 1 on 2 times, integrate x with respect to the x, we have x squared on 2, putting that in bracket, this integration sign please. So I have integral of that. So the rest here is just simplification. Yes, you don't need to simplify this much as possible to arrive at the right answer. So let's continue. So you have this is equals to x cubed minus, so we have x squared on 4 plus a constant of integration, which is c. So we are done with that. That was number 4. Remember the ILATE, we have not touched what we call, let me see, I want us to touch all the poem here on ILATE. Now we already had, looking at ILATE, we already had inverse trig function. We have touched equation on that. We have done equation on inverse. We have touched this inverse trig function. We have touched logarithmic. We have touched algebraic. We have touched this. We have exponential, which is the last one that we're going to touch. Once we touch this, that will be the end of the video. So let's take number 5, which is the last point. So we're going to be taking integral of, let me say, 2x e to the 4x dx. So this exponential, so that's exponential. So let's take equation on that and we'll solve. So let's move ahead. So for this we are going to have u, let u equals to, when we look at ILATE, which one comes first? We have algebra and exponential is the last. So we are going to say let u equals to 2x. Let u equals to 2x. And we have du is equals to, when you differentiate this, you are going to obtain 2 with respect to what? Dx. Now let's move ahead. We also have dv. So dv will be equals to e to the what? 4x. When we look at that, that's 4 to the, that's e to the 4x. So now we have integrating both sides, we are going to obtain v equals to, now you are going to take 1 divided by, you differentiate the power, which is 4, then you copy it back. So that is it. So now the next thing we are going to do is we are going to substitute them directly. So when we are doing that substitution, let's move ahead. We have uv. What is our u? Our u is 2x. So we have 2x times 1 on 4 e to the 4x minus. Now what are we going to have? We have integral of v, which is, and what is our v here? Our v here is 1/4 of that. So let me write that. So I have integral of v. I can factor out that 1/4. Then I'll send this inside. Du. Where is our du? Let me look for du. Our du is 2x, 2 dx. So times 2 dx again that 2 can be factored out, so let me put the 2 out, put the 2 here, dx, and again 2 on 4 is half, so instead of writing this I'll put just a half, so I'll put just a half. That's it. So the rest now is just to simplify, just to integrate. Please, if you have any question, please, like I said before, send your question. It will be solved as the next video. Share this video much as possible too, so that you encourage me to solve more questions like this. Now these 2 can cancel out. With these 2 we are left with 1 on what? We are left with 1 on 2 e to the 4x minus, when you integrate e to the, now we have half into, when you integrate this you are going to have 1 on 4 e to the what? 4x plus c. So looking at this, plus c, which is equals to, so we'll have, let me 1 times that, so we'll have e to the what? 4x divided by 2 minus e to the 4x on 8 plus c. So this is the n, where you can factor out, e to the 4x on 2, so that you have 1 minus, remember if you are doing that, means you have 1 minus, because this divided by this, that is 1, this you are taking e to the 4x divided by 8, all that on this. Now some students might find difficulties doing this here, so you have minus 1 on 4 plus c. If you open the bracket, multiply this, you have that, multiply this, you see have what we had above, and you can further simplify this. 1 minus 1/4, that's 1 minus 1 on 4, so you have 4 minus 1, that's 3/4, so we have 3/4, so we have 3 on 4, to have e to the what? So we have e to the 4x on 2. It's always good to simplify your answer much as possible. It's very important. You have 3 on 4 plus c. So you see that this will be the best simplification so far. So at the end of the day, we have that is equals to, so we have 3 e to the what? 4x divided by 8 plus c, and that is your final answer. We have come to the end of this video. This is the end of the video. Now you can do this one as on your own when you are free. Let me say this is a question that you are going to solve, and you present your answer. You have e to the 3x, you have sine inverse of x dx. So you can solve this question and you submit your answer or your solution in the comment section. I'll go through the question. If at least 5 people solve this question and comment, I will do the correction for this. Thanks for watching the video. Bye bye.